On October 29th, 2022, there was a panic in South Korea that led to over 158 deaths. Now, it wasn't an actual attack or a lack of security, but rather it was a problem controlling a crowd. Now imagine, we're in the midst of a real attack. What do we do? The risk of not having proper crowd control can lead to mass hysteria and results in an even more dangerous situation. With 173 mass attacks committed from 2016 to 2020, the US must have proper crowd control mechanisms in place to combat a greater loss of life and help crowds make good decisions in attacks such as bombings, chemical warfare, and mass shootings directed at soft targets.
Our task at hand is to find an effective and easily communicatable means of crowd control that enables crowds to make good decisions in the midst of terror. Today, we have chosen to focus on Petco Park. At Petco Park, the stadium is equipped with CCTVs and a current evacuation plan that will simply alert the crowd of an attack and order them to find the nearest exit. But in a major event, that may not be possible. In San Diego, the average response time for Priority Zero emergencies is 6.7 minutes. So it is critical that a system directs a crowd in a rapid format. We have deduced that the biggest contributor to chaos in these crowd controlling situations is the lack of pertinent information provided to those in danger.
Our solution builds upon existing infrastructure to learn about a crowd's movement and provide the best evacuation plan. We are proposing the use of thermal sensors to determine the density while using radar and CCT computer vision to depict the crowd's behavior. To optimize controlling a crowd, you need to think with your dome.
Detection, observation, mapping, evacuation.
Detection will be done through radar and thermal sensors using machine learning and AI algorithms. Observation will be triggered through anomalies in the thermal and radar sensors, alerting the operator of the attack. Mapping will use predetermined exits to determine optimal paths for crowds to leave through, based on their current location. To optimize these paths, we are prioritizing localization of containment of the threat. Finally, our evacuation tactic will be based upon treating the large crowds as a fluid traveling through the stadium.
In order to keep track of how many people are within an area,
each access point within this room will be equipped with a radar. The radar we have for demonstration is the Infineon XENSIV 60 GHz radar, which is capable of tracking the presence and movement of people very accurately. By vectorizing incoming and outgoing foot traffic, we're capable of quantifying the exact number of people. This number can be used to scale the sensitivity of the thermal imaging algorithm. Every high-tech solution needs redundancy. Our camera simulation is set up to detect entry and exit of patrons and personnel. We're utilizing computer vision to enable motion detection and validation of our sensor platform. Also, crowds move like waves. The most effective way to quantify human movement is to model crowds as if they were fluids. Each human emits a thermal heat signature which ranges between 80 to 97 degrees. By analyzing the raw data, which is captured with an infrared thermal camera, we can build models of nominal human behavior within different rooms and environments. On a typical day, the arrangement of people sitting here would be evenly distributed throughout the table, sitting on each of these individual seats. Now, let's take the thermal heat signature of this, for example.
By training a deep neural network to recognize that this is a normal topographical distribution of people in the conference room, we can infer that in a situation like this, there's obviously something wrong with what's going on in the room. By using reinforcement learning to teach a computer what to look out for, we are able to give precedence to security operators and higher level omniscient systems to manage the movement of a crowd.
This system is designed to be implemented on present-day access control systems. Companies that offer motorized access control doors include Allegiant, Assa Abloy, and Honeywell. This algorithm allows for a computer to find the shortest possible path through a maze. By utilizing software that can control motorized doors, we can guide the crowd in the general direction of the best decided safety.
During a moment of crisis, there will be mass hysteria, with everyone only having one thing on their mind: the survival of themselves and their loved ones. Being able to integrate the data that we've gathered, unite it, and display it in the simplest way possible allows for the crowd to make the best possible decision without thinking. Attacks can happen at any location in the stadium. For example, it could be behind home plate, in the visitor's bullpen, or even in the nosebleeds. Being able to identify the location of the attack would allow for disabling certain exit nodes and redirecting crowds to the nearest available exit through in-place infrastructure such as concession stand TVs, or even the Jumbotron.
After collecting and analyzing the data from our sensors, the system should be placed into the evacuation state, in which low-power LED lights located around the stadium on the floors, walls, and ceilings, similar to those in airplanes, will be activated to dynamically point in the direction of the nearest available exit.
One of the best aspects of this solution is the scalability and ease of guiding the crowd. The thermal imaging and radar system provide for a non-invasive form of monitoring, allowing for the ability to implement this in schools, public transportation, and other soft target areas. Our solution offers a high reliability, low cost, and straightforward action plan for getting people to safety.